All right, so like I said, I gave you this last week Wednesday, and I said, give it a try if you could. So the first angle we were asked was angle P, which is the yellow angle that I indicated there. Now remember, angles in a cyclic quad have relationships with each other, whether it's an exterior angle, opposite angle, etc. Now, because MNPR is a cyclic quad, and I know that because all 4 vertices are on the circumference, I can use the relationship that says opposite angles are supplementary or add up to 180. So essentially, angle P would be 180 minus 64, which is 116 degrees. And your reason op angles of cyclic quad. I am doubting my math there. Let me just double check. 180 minus 64, 160. Okay, don't have to doubt my math. All right, so that was the first one. Second angle we were asked for is angle M1. So again, it's the angle that I indicated in green. Now, angle M1, we've just found, oops. Right, angle M1 is up sort of as part of angle M, the whole angle M. Now, remember, we were told that O is the center of the circle, which means that this line SON going through the center of my circle is a diameter. And we know that angles subtended by diameters are 90 degrees. So that whole angle M, so SMN, the whole thing, is equal to 90. You don't have to write this down. You can go straight to your answer. I'm just laying it out because of angles in semicircle. And because I know that the whole thing must be 90, and I already have 64 degrees of that 90, if I subtract 64 from 90, I get M1. And so M1 is equal to 26 degrees. You could just go straight to your answer with this reason, angles in semicircle. You don't need to write SMN equals 90. I was just really being clear about what was going on. Okay, and then the last angle we had to find was angle O1, again, labeled here in red. Now, O1 is a reason that I feel like sometimes we struggle with if it's not the obvious. Now, what I want you to notice is that angle O1 is an angle at the center. And from that same sort of imaginary chord SR, we also have an angle subtended at our circumference. And so what we actually have here is angle at center equals 2 times angle. No, let's try that again. Yeah, angle at center equals 2 times angle at circumference. Now, because we know the angle at the circumference, which we've just worked out to be 26 degrees, I know that the angle at the center is double that. So angle O1 is equal to 52 degrees because angle, I don't even know, angle at center equals 2 times angle at circumference. And this was quite a hard one to see because it almost looks like angles in same seg, but because one angle's at the center and one angle's at the circumference, we need to be very, very careful. Okay, so those were the 3 angles that you needed to find. I'm hoping that we got them correct. I'll leave it up there if you want to take a screenshot, but like I say, that was what we finished off on Wednesday, and I said, try it, we'll have a look on Monday, which is what we've just done. All right, so the one that I think was probably trickiest was this last one because it's a weird angle at center, angle at circumference situation. We're used to having angle at center, angle at circumference. That's what we're used to, but it doesn't always have to be like that. Alrighty. Okay, so I'm just going to wait another 5 seconds in case you want to take screenshots. Okay, I've got a question. I use angle centered for O1, perfect, and then angles on a straight line to find O2, perfect. So if we needed to find O2, absolutely, because we now know that this is 52 degrees, we definitely can use angles on a straight line. That is absolutely 100% perfect. Okay, guys, awesome. So let's get into today's stuff. So just a few quick friendly reminders for you guys. Then I mute myself because, you know, why not? Just make this a bit smaller. Right, so a few little things. Firstly, don't forget boot camps, starting not this weekend, next weekend. So these dates are a little different to what we initially had. Just some feedback from parents, students. We're going to be doing 3 sessions for the matrics, paper 1, paper 2, and then sort of like a wrap-up session. These will start on the 4th of May. So like I say, not this coming weekend, next weekend. They're an hour and a half, and for all 3 sessions, it's $4.49. So again, hour and a half, exam prep, we're going to be going through past papers, how to answer questions, the types of questions you need to look out for when you're studying, how to approach your studying, all of those things that you need for these upcoming June exams. I know we start June exams in like 3 weeks. Some schools, the matric start even earlier than everyone else. So these June exams are here. We need to be ready for them. So please feel free, obviously, to share this with whomever you want. Please sign up if you're keen and you think it's going to help. But just take note of the dates down here, that you are ready and that you're prepared. All right, then just the other thing. Yeah, I don't know where I was going with that thought. Anyhow, I've uploaded some stuff on Google Classroom, and I'll mention it a bit later as we get into the lesson. And obviously, geometry is a hugely important section that you need to be revising, by yourself. So I will upload a few more or a few worksheets on just circle geometry practice, because that really is the bulk of the geometry in your papers. All right, but guys, what we are going to have a look at today is the proportionality theorem. Some people call it the proportionality intercept theorem. That's just too many words. I'm not going to call it that. Proportionality or prop theorem even is absolutely fine. And this theorem talks specifically in triangles, and it talks specifically about the relationship or the ratios between sides within a triangle. Okay, so to start off with, we need to actually understand what this theorem is, what it says to us, and how in turn we can go and use it. So that's what this situation I have going on here is talking to us about. So the proportionality theorem says a line drawn parallel to one side of a triangle cuts the other 2 sides proportionally. So this is a really important thing. I'm not saying that it cuts them so that they're equal in length. I'm saying that it cuts them in proportion. So a line drawn parallel to one side. So there's my line drawn parallel to side BC in my triangle, cuts the other sides proportionally. So when I say, let's maybe do this. So a line drawn parallel is in the light blue. When I say other sides, I'm talking about the sides I'm about to highlight in yellow. So this would be side AB and side AC. The side BC at the bottom there does not feature. It's got nothing to do with the proportion because it's not being cut by the parallel line. It's the side that the line PQ is parallel to, but it does not feature in the proportion relationship. Okay, so that's the first really important thing that we need to understand there. The second thing that we need to understand is, well, that's great. What does proportion mean? So, for example, if I told you that this was 25 centimeters and this was, I'm obviously now panicking, of course, and this was 5 centimeters, I'm just going to make it up. So 25 and 5. What I see is that this length up here is 5 times my bottom length. And so that must then be true on the other side. It must be in proportion. It must also be 5 times. So if this was 6 centimeters, this would be 30 centimeters. They are in proportion to each other. If I worked out a ratio, I would get the same ratio on the left as I do on the right. That is what in proportion means. Okay, so if we go back to the theorem, that's what we have. We've got our parallel lines. That's cutting my other sides in proportion. And this proportion idea is now highlighted by these ratios over here. So if we go and have a look, AP is this length here to PB is in proportion to AQ to QC. Now, see how AP matches up with QC? Let's do that. Oi, oi, oi. Someone has to actually use technology every day. Really doesn't go well for me. Okay, whatever. We're giving up on that fight. So if you have a look, AP and AQ, those correspond with each other. They are both the top segments of my triangle, or the top segments of each side of my triangle that's been cut proportionally. If I then go and have a look at PB and QC, those are the bottom segments of my triangle. So they all correspond and correlate with each other. So again, if we have this line drawn parallel to one side of my triangle, I can now conclude that the sides are in proportion with each other. Now, obviously, this is geometry. Anytime we're dealing with geometry, we have to have a reason. There are two options. I would never use this whole long situation over there. I'll write the shortened version now in a second, because really that's just silly. So your first reason is prop theorem, which I'll write for you now, and then you state your parallel lines. Your second option is to have line parallel to one side of triangle. I don't care which one you use, okay? I'm going to use the first one just because it's the one I'm used to and the one that for me is shorter. So you can say prop theorem. And then we always state the parallel lines when using prop theorem as our reason. So PQ parallel to BC. So these are the two reasons that you will use when working with prop theorem. Either prop theorem, PQ parallel to BC, or line parallel to one side triangle. Makes no difference which one you choose to use. Use the one you're more comfortable with. If you know you always forget your parallel line reasons, don't use the one where you have to write parallel lines. Okay, really up to you. So this is what our theorem does. We obviously now need to be able to go and apply this theorem. Now, another thing that I want you guys to remember is that anytime in geometry we have a theorem, there's a proof for that theorem. I'm not going to go through the proof, but I have uploaded the proof onto Google Classroom for you guys to have a look at. It's not a hard proof, but yeah, it's one of those things, and I've said this to you before. Either you are going to learn your proofs and you're going to bank those 5-6 marks on your test or your exam, or you're sacrificing those 5 or 6 marks, but you are making very sure that you're picking them up somewhere else. You do you. It is a question that you will get. There is no question about it. In paper 2, June, mocks finals, you are going to be asked a question that asks you to prove a theorem in Euclidean geometry. Now, this particular theorem, I have not seen asked, I don't want to say ever, because that's probably not true, and I have not investigated that far, but in the last 5-6 years, never seen the prop theorem asked as a proof. It's usually a circle theorem. I am not by any means saying that they will never ask you the prop theorem proof, because they can. I've just never seen it asked in the last 5 to 6 years. Maybe this year is the year. So it's on Google Classroom for you guys. It's there for you to learn. You do with it what you will. Right, I'm just going to wait here in case you guys want to take a screenshot. And then we're going to have a look at our first example where we actually now use this prop theorem in finding unknown side lengths. Okay, so let's have a look at our first example. So guys, we're starting off basics. Next week, we're going to amp it up again, because what you're going to see is that once you've done the proportion theorem, and on Wednesday, we're going to talk about similarity again, which is something you last spoke about probably in grade 9. These questions are often asked in conjunction. So proportionality and similarity go hand in hand. So we need to have both of those basics down before we can move on to the more complex stuff. So this week is basics. Next week, we're stepping it up. So again, some of these examples might seem very basic, and they are, but that's because if we can't do the basics, we're not going to be able to do the other stuff. All right, so example 1, this is basic. I expect you to think, what on earth is this woman doing? Why am I being asked to write down ratios? Well, it's because if you don't understand a ratio, you're not going to understand the prop theorem. Alrighty, so, sorry. Let's have a look and see what we're working with here. So I've asked you to refer to the figure and just fill in some ratios. Look at it and write it down. That's all I'm asking from you. So I'll do a couple with you, but you're going to do some by yourselves. And again, it's not because I think you can't do it, but it's because we can set up ratios in so many different ways. We need to be comfortable with it, because we're going to need to get to a point where I look at a diagram and I say, okay, this is the information I have. This is what I'm looking for. This ratio makes the most sense. So we've been given triangle PQR with a parallel line XY parallel to QR. So yeah, because we've got a line drawn parallel to one side of my triangle, I know that the proportion theorem applies here. So they're my parallel lines. You can highlight them if you want to, you do you. We now need to set up some ratios. So I'm going to use colors because this is the way my brain works. If your brain doesn't work like that, that's cool. So we've got PY, hello, no, okay, cool. PY, we got there in the end, which is this side length over here over YR. So that's in green. So it's basically the top segment on the right-hand side. Thank gosh, I'm not a driving instructor. Top segment on the right-hand side over bottom segment on the right-hand side. That means that my corresponding ratio must be top segment on the left-hand side over bottom segment on the left-hand side. And that's exactly what we're going to write down. So in my numerator, I've got top segment. So it would be PX. I could write PX in my numerator. It's a weird looking P. I do apologize. That is a P. Cool. There we go. Weird looking P, but PX over the bottom segment, which is XQ. And that's a ratio. That is a true ratio because those sides are in proportion with each other. And I have got a potential ratio that I can use. Obviously, we'd have our reason, prop theorem, parallel lines, all that stuff. But this is one of the ratios that I can set up in this specific triangle. Just one. There's many. So if we move over to the next one, we have been given XQ, which is this line segment at the bottom here, over XP. So XP is now the top line segment. So do you see how it's basically the same as what I just did, but now it's reversed? It's now bottom segment in comparison to top segment, whereas the last was top segment in comparison to bottom. So now we go and have a look at what correlates. So XQ correlates to YR, so that will go into my numerator of the unknown fraction, YR. And XP, so the top segment here in orange, corresponds to PY. And so that will be my denominator of my second fraction. Again, pretty much the same thing as what we were talking about in the first one, but we flipped it. It's now bottom segment in comparison to top segment. There's nothing wrong with that. And this is what I was saying earlier. You're eventually going to have to start looking at your diagrams and looking at the information you've been given to decide how should you be setting up your ratios to make the most sense for you. Right, if we have a look at the third one, we've got PY over PR. So let's have a look here. PY, which is the top line segment, over PR. Now we just need to be careful. PR is the entire side length. Again, nothing wrong with that. It's part of the line segment that I'm working with. So if we now go look at what corresponds, PY corresponds with PX. So that will go in the numerator. So PY corresponds with PX. And PR, so the whole side length, corresponds with the whole side length on the other side, PQ. And so that will now be my denominator, PX over PQ. So there is nothing wrong. There's nothing saying that you have to work segment by segment or segment in proportion to segment. You can use the whole side length if you want to. Again, it's dependent on the information you've been given, but you can do it. And so understanding that there's so many different ways to write these ratios is going to help you realize that when setting up a solution to a question, you set it up that makes most sense for the question. All right, so I want you to try to do these last two ratios for me. I'll give you 2 minutes. You can put answers in the chat. I will ask you in 2 minutes to give me some answers. So hopefully someone's feeling brave. But let's try these two and then we'll have a look at actually now a triangle where we have to find an unknown length. Like what I'm seeing so far, guys. Well done. And remember, in geometry and like your exams, you get a book, an answer book for paper 2. So what that means is you will get all of these diagrams reprinted where you're going to write your answers. So when it comes to that, highlight, draw, scribble, do what you need to do so that you can get the marks for your questions. Okay, let's have a look. Is anyone feeling brave and would like to give me the first ratio? So we've got PQ over XQ. Does anyone want to tell me what that proportion fraction ratio should look like? You can just unmute yourselves.
PY over YR.
Nice. I don't even know who was speaking to me. I'm so sorry. I feel so rude. I'm sorry. Who gave me that answer? I was not focused. I did not see Siba.
Plus Siba, ma'am.
Thank you, Siba. Sorry, I did think it was you, but then I panicked. Okay. So exactly PR over YR. Just so we're all clear, PQ whole side length, XQ bottom segment. So we've got on the other side, whole side length PR, bottom segment YR. Perfect, no issues. Who wants to give me the last one here? A little different. So in one fraction, we've got PQ in the numerator, and in the other fraction, we've got PY in the denominator. I've seen some great answers come through on the chat.
Ma'am, the first denominator is PX
Thank you, Siba.
and the numerator is PY. I mean PR.
PR, good. Okay, exactly. Now this one a bit tricky because it was like a weird situation, but PQ, whole side length, which means this numerator must be the whole side length, which is exactly what Siba said. PY is the top segment. So on the other side, top segment, which is PX. All right, so guys, so many different ways to set up ratios. You're going to decide which works best for you based on the question. Okay, thank you, Siba, for helping me out. I appreciate it. And well done to everyone who gave me answers on the chat. Awesome answers. If you want to take a screenshot, I'll wait 5 seconds, but let's get into it now. Okay, so what we need to essentially be able to do is apply this to triangles because that's what the prop theorem talks about. So again, starting off easy, we'll build up to the hard stuff. We've been told that in the diagram below, AB is equal to 12 centimeters, FB is equal to 3 centimeters, and GC is 14. Calculate the length of AG. So we've been given that information, but hopefully what you can also see on the diagram is that you've been given parallel lines. Panic. So we know that FG is parallel to BC. The second I see one side and a line parallel to it, I should be thinking of prop theorem. I'm going to fill in the information I have. So AB, which is this whole side length, is 12 centimeters. And this is what I'm saying, scribble on your diagrams, fill things in. FB, so this bottom segment down here is 3 centimeters. And GC is 14 centimeters. What I am looking for is the length of AG. So I'm going to highlight that in red for us. So that's the length I'm looking for. Cool. So the way I approach these questions, guys, is I start by setting up a ratio. Now, this ratio obviously must include the thing I'm looking for, and that would be my very first fractions numerator. The reason I'm saying put your unknown in the numerator is because it's so much easier to solve. So the unknown that I have here is AG, so I'm going to start with that. AG over. Now I have to set up those ratios. Now remember, there's many, many different ratios that you can set up here. We need to decide which is going to work. The way I decide what other line segment to include here is I look at the information given to me. AG is what I want. I was given on the same side GC. So let's use that. So I'm going to have AG over GC is equal to, and I set up my proportion. So AG is in proportion or corresponds to AF, and GC corresponds to FB. Sorted. Proportion set up, no problem. Remember your reason, prop theorem. And if you're going to use prop theorem, you have to state your parallel line. So BC parallel to FG, or you're using line parallel to one side of triangle. I just find it too wordy and I'm lazy and I don't want to use that. You can use that if you want to. Now that I've set up my ratio, I start filling in the information that I know. AG, obviously, I don't know. That's what I'm trying to find. So AG over. GC was 14 centimeters. AF, not just, we don't have to panic, okay? AF, I don't actually know the length of, but because I know the whole length AB, and I know FB is 3, to get AF, I just subtract the 2. So AF is equal to 12 minus 3, which is 9 centimeters. Now, you don't even have to write that down. You can literally just write down 9 in your working out. We trust that you can subtract. And FB, I was given as 3 centimeters. Now I solve for AG. AG is equal to 9 over 3 times 14. Now remember, I'm multiplying by 14 because I want to get rid of this denominator. So I would times both sides by 14 to get rid of my fraction. Okay, so 10 seconds. Someone either unmute yourself, tell me, or just put in the chat. What is 9 over 3 times 14? What is the length of AG? Nice. I've lost my pen. Found my pen. Nice, guys. Well done. Well done. Okay, so this is 42. Now it is in centimeters. We're not super strict about units. So if you just write 42, that's fine. I'm pedantic about units, but that's a personal issue I have. If you leave off the centimeters, you're okay. We're not going to mark you down for leaving off a unit. It is absolutely fine. Okay, but that's it. So what you want to do is you want to look at what your unknown is. That's what you put in your first fractions numerator. Obviously, sometimes as the questions get more complex, that isn't necessarily always possible, but you try and do it like that because it is just going to make your life 10 times easier. Once you've done that, you set up your ratio according to what you know. So because of the information I knew, I set up my ratio like this. I could have set it up in many other ways, but this was the easiest based on what I had. Okay, so take a screenshot and then let's have a look at another one where we're going to apply the same logic. And guys, don't forget, if you have questions, please just ask. You're welcome to obviously just unmute yourself. You can put it in the chat, whatever you're more comfortable with, it's completely up to you. Right, let's have a look. Okay, so example 3. Now, what I want you to notice, and we're not going to panic about it, is usually, or typically my parallel line sits like this, so as horizontal lines. But what you can now see in example 3 is that we're not doing that, but that's fine. There's nothing wrong with that. It doesn't matter if I mix things up a little bit, right? So we've got our parallel lines, which are BD and AE. Now remember, the sides that you're working with in terms of your proportion are the sides that are being cut by that parallel line. So that would be AC and CE. AE does not feature here because AE is not being cut by any of my parallel lines. So it can't be cut proportionally because it's not being cut. Right, so that's my tangent. So we've been given in triangle ACE, BD is parallel to AE. Calculate the value of Y. So again, let's just assess what information I do actually have. So here's Y. Y is the line segment AB. So that's what I'm trying to solve for. That's the unknown I want. I have been given, excuse me, the whole side length AC. I've been given CD is 24 and DE is 18. Now, technically what that means, guys, is you do actually know the whole side length CE. If you just added those two values together, you would obviously get the whole side length CE. So just something to bear in mind, same as in the last question, I did actually know what AF was I needed to subtract. So always just remember, based on the information you have, you might actually have a little bit more than what's right in front of your face. So we want the value of Y. So again, we set up our ratio based on our first fractions numerator being what we want to know. So we want to know what AB is. Now I set up my ratio. If I look at this side AC, the line essentially segment AB is on. The other bit of information I have is the whole length AC. So that's what I'm going to do. AB over AC is equal to, now I set up my proportion. AB corresponds to DE. So DE over the whole side length CE. Prop theorem as my reason, or line parallel to one side triangle, whatever you decide. And we state our parallel lines, BD is parallel to AE. Obviously, if you swap them the other way, it's fine. Okay, now I start to fill in what I know. So AB is Y, AC is 35, DE is 18. Oh, maybe I should put an equals 18. And CE, like I said, is just 24 plus 18, which is 42. And I solve. So Y would be equal to 18 over 42 times 35. And just chuck that into your calculator. So I'm seeing some answers on the chat. Let's see if we can all agree. So we've got 15, we've got 20. I'm going to agree with one of them. Okay, good. So Y is equal to 15 centimeters. Again, if you leave off the units, it's really not the end of the world. I'm just pedantic. Okay, it's absolutely fine. So exactly, Y is equal to 15 centimeters. Now remember, guys, you can go and check. If you want to check if your answer is right, check that they're in proportion. So we decided that our ratio would be AB over AC is equal to DE over CE. So AB, we've just worked out to be 15 over AC, which is 35. That ratio simplifies to 3 over 7. DE to CE, so DE is 18, CE is 42. Those can both be divided by 6, giving us 3 over 7. 3 over 7 is equal to 3 over 7. They're in proportion with each other. And so the answer we've gotten is correct. So you can always check yourself if you're not 100% sure by making sure that the values you now have do actually give you a proportion that's equal to each other. So always, and the reason I'm pointing this out is if we've got ways to check ourselves, let's do it. Especially when we're sitting and twiddling our thumbs for the last 10 minutes, check your work. Okay, so let's take a screenshot and then you're going to try one by yourselves. And remember, guys, if you've got questions, please ask, put them in the chat, unmute yourself if you want. It's absolutely fine. but please do make sure you're asking. Okay. So I want you guys to try this one by yourselves. Nothing too stressful. Straightforward, nice and easy. Don't panic. Start with what you want. Start with setting up your ratios according to the information you have. And let's solve for x. I'm going to give you 2-3 minutes, and then we'll have a look. Okay, while you're busy, there's a question of when will we do 2D and 3D trig. So just remember, guys, I said that we only have a general trig course. I'm also saying this, as far as I remember, we have a general trig course this year. And so trig functions and 2D and 3D trig, we won't necessarily cover. We will do them in the paper 2 boot camp. So that's what I'm saying, sign up for boot camps, because we've got a bit more time to then do specific questions. But what I will do is I will put some questions together for you guys to practice and put them on Google Classroom. But as I explained in our trig section, the bulk of trig in your paper is general trig. So simplifying expressions, proving identities, cast diagrams, trig on the Cartesian plane, stuff like that. The equations and the 2D and 3D trig is not a big part of trig in your papers. So that's why I'm not necessarily focusing on it. But I will put some revision up for you guys. And like I say, hopefully in the boot camps, we'll get to some of those questions. But again, because it's such a small section, it's not going to be a huge focus. So, I mean, I'm sure you guys will be finding this as well at school. Unfortunately, matric, we have to pick what's important and focus on that. So we're not going to actually do a whole course on it, but I will try put some revision up for you guys to practice it. Okay, I'm going to give you 1 more minute and then we'll have a look. Yeah, I like these answers. Nice, guys. Okay, so if we just have a look, we've been given a triangle where PQ is parallel to BC. And so that means we've got proportion theorem happening. We are looking for X, so bear that in mind as you start to set up your ratios. But if we have a look, this is essentially what we need to be doing. So we've got QC, which is X, over AQ, because we were given that 4, is equal to BP over AP or PA, whatever. You substitute in what you know, and you get X is 2, 4. Now, again, guys, there's lots of different ways you could have set this up, and that's completely up to you. But start with what you want, and then try and use the information that you have around that value or given to you in the question in order to solve for your unknown. Right, but it looks like we got 2, 4 from most of us who put answers on the chat, which is awesome. Actually, everyone who put answers on the chat. So that's great. Okay, so let's have a look at another. So this example is now where the algebra, and I don't want to say it gets more complicated, but where we need to bear in mind that algebra comes in everywhere. Okay, we saw it in trig, we've seen it in geometry, obviously algebra, functions, pretty much everything we do in maths involves algebra. So we need to bear this in mind. Now, this one is quite an easy one, but there are ones where you can end up with like quadratic equations that you need to solve, and we'll do an example next week when we do look at more complex type questions. But just, this is why like we harp on about revise your grade 11 algebra and make sure you're comfortable with algebra. It comes in everywhere, so you have to be comfortable with it. Okay, so in this triangle, we're told that GH is parallel to EF. So again, we've got proportion. So we can start setting up what we want, and we are looking for the value of M. Now, if you have a look, let's not say the problem, but what we need to be mindful of is the fact that M is in 2 places. M is the length given to me for DG, and M plus 2 is the length given for me for DH. So we just need to be careful there. Now, what's quite nice is that DG and DH are the top segments of my triangle, so I can keep them in my numerator when comparing. So I'm going to have DG as one numerator and DH as the other numerator. Now I have to decide what my denominator should be. Now, given the fact on both sides, I'm given the bottom section, that's what I'm going to do. So DG over GE is equal to DH over HF. Prop theorem, GH parallel to EF. Now I start substituting what I know. So I know DG was M, GE was 2, M 2 is equal to DH, which is M plus 2 over HF, which is 3. Now I've got an equation I can solve. Now, guys, because there's one fraction on either side of your equal sign here, what you can just do is you can cross multiply. So that means we're going to multiply M plus 2 by 2, M plus 2 by 2, and we're going to multiply the M by 3. Cross multiplication in this case, when there's one fraction on either side, is basically a shortcut to finding an LCD. You obviously can find an LCD as you're used to, but once you have one fraction on either side, just cross multiply your denominators. Like I said, it's a shortcut for getting an LCD. So we've got 3m is equal to 2m plus 4, because remember, I would distribute that 2 into my bracket. And so I get that m is equal to 4 units. Again, you can just say m equals 4. You don't have to write units. So sometimes there might be multiple terms or multiple segments where you have a variable, but you just solve your equation. Like I say, they can become more complex, and we'll do examples like that next week, where we do start to increase our complexity levels. But again, know your algebra, know how to distribute, know how to factorize, know how to solve a quadratic equation, know how to solve a linear equation. If you can do those things, you can do this, because that's all it is. It's just algebra. Okay, so let's screenshot. Let's have a look at another example. And this time we have two triangles, and we just have to bear in mind that sometimes we just can't go straight to an answer. We have to do a little bit of work beforehand. And again, if you've got questions, please ask. I know that geometry isn't necessarily everyone's favorite section. I know that proportion isn't necessarily everyone's favorite section within geometry. I personally do not like proportion. I don't know why, I just don't. I'd much rather have some circle geometry, but we have to know it and we have to be able to apply it. Okay. So if we have a look at example 5, like I said, we've got two triangles here. Now, this is not something we need to be scared of. It's not something that needs to stress us out. It's not something that we now need to panic. We just have to read our information really carefully, make sure we know what's going on. And this is where, again, use colors, highlight, do what you need to do to make it make sense. So we've got triangle ACF. So ACF is this green triangle on the right-hand side of my diagram. In this triangle, I have been told that AF is parallel to BG. So AF, terrible highlighting skills, is parallel to BG. First bit of information. Second bit of information I was given is the fact that in triangle CEF, so this orange triangle here on the left-hand side, in this triangle, I once again have some parallel lines. EF parallel to DG. Now they're in two different colors because not all of these parallel lines are all parallel to each other. Sounds like a lot of words, but we've got two sets of parallel lines that are clearly much steeper than the next set of parallel lines. So we need to be careful. Then I've been given a whole bunch of information about the lengths in my triangles. So I've been told ED is 22 centimeters, DC is 33 centimeters, BC is 15 centimeters, and AB is X centimeters. And shock horror, I have been asked to find the value of x. Okay, so we know exactly where x is. The problem I'm facing right now, though, is that I can't go straight to x. I don't have enough information in this green triangle to just go and work out x. I've got no information about FG or GC, which means I can't set up a proportion and just solve like I have been doing previously. I just don't have enough information. Okay, but what we need to bear in mind is that we've got this orange triangle. And in this orange triangle, I have got two side lengths that if I now set up a proportion, can give me the proportion of FG to GC, which is what I want, so that I can then move on to AB to BC. So we have to look at it as a process. I have to get the first bit of information before I can get the second bit of information. Okay, so we're going to start in the orange triangle, and we're going to set up our proportion. So we know that ED, and it doesn't matter what order you choose to do it, I'm starting with ED in my numerator though, because I know that ED will relate to FG, and FG will then relate to AB, and AB is the unknown. So remember I said always try to get your unknown in the numerator. But again, if you did it the other way, it's really not going to make a difference, okay? So ED to DC is equal to FG to GC. Prop theorem. And again, because I'm in my orange triangle, it is EF parallel to DG. Great. Now remember, you know both ED and DC. So ED over DC, oh, please don't hate me right now. It's going to hate me right now. ED over DC is equal to 22 over 33, which is equal to 2 over 3. And remember, we've just made the statement that this ratio is the same as FG over GC. So that means FG over GC is also equal to 2 over 3. And that all links to what I said up here. I'm going to move it so that we can actually have some logic to the situation. So because I've already said that they're equal, once I know the ratio for ED over DC, I automatically know the ratio for FG over GC. So now I know this. This is 2 parts to 3 parts. Now I'm using the word parts here, guys, because remember, this is not 2 centimeters is to 3 centimeters. It's a ratio. I have no idea what those lengths are, but I know it's in a proportion of 2 is to 3. So it's not a length, but it is the proportion that I can use. Now that I have that, awesome. I can now work in my green triangle to work out what I want to work out. Excuse me. So I know, and remember, I'm looking for AB, so I'll chuck that in my numerator, over BC, because that's the information I have on the right-hand side, is equal to AB corresponds to FG over GC. Again, prop theorem, all of that fun stuff. I'm in a new triangle, so now it's AF parallel to BG. Now, if you have a look, FG to GC is exactly what we just found. So I've got that information, which is wonderful. AB we were told is X. And BC we know is 15. And we've just worked out that FG to GC is 2 over 3. And now I just go and solve. Okay, so 30 seconds. Quickly tell me what the length of X is. Some of you are on it. Nice, guys. Exactly. X is equal to 10 centimeters. Right, so sometimes, yeah, we just got to do a little bit of extra work. But what you need to remember is that once you have a proportion set up in a triangle, if that triangle now links with another, or you can set up another proportion using that information, do it, okay? There's all links because of those parallel line lengths and the ratios or proportions linking up with each other. So yes, sometimes we have to do a little bit of extra work. There's nothing wrong with that. But take careful note of how your proportions that you have or the information that you have can lead you to where you need to be. So let's take a screenshot, and then in these last 8 minutes, you're going to try one by yourself. I can't remember what the question was. Can't remember how mean I was. Let's put it like that. I'm not usually very mean. Okay. Oh no, I wasn't too mean. Right, so I want you to try this one. There's 3 parts to this question though. So there's the length of BC, the value of AG over GD. So what is the proportion, the ratio, and then the length of FE. Right, have a try, have a go. Let's see. You might need a bit more time, so we can always make a call towards the end if you would like to carry it over to Wednesday, and then we'll have a look at the answer on Wednesday. But let's see, I'm going to give you 5 minutes. Give it a try. If you need more time, we can carry it over to Wednesday and we can have a look at it then. But let's try this for now. The thing I am going to say, sorry, I need to learn to just not talk. But the thing I am going to say is, take note of this bit of information over here in yellow. I'm giving you essentially a ratio. I'm giving you a proportion. So just take note of that. Obviously, you've got AB is 21 and AE is 20. Also important bits of information. But take note of the fact that I'm actually giving you a ratio of AB to BC. I'm giving you the proportion. Right, I'm going to stop talking. And guys, just remember, a ratio is not lengths. So I'm not saying AB is 7, which is obviously clearly not the case because AB we've been told is 21. I'm telling you it's a ratio. Yes, I have made that point before, but just bear it in mind. Okay, guys, can you just give me a thumbs up if you're ready, or a thumbs down if you want to carry this over to Wednesday, and we'll have a look then? Because it looks like some of you are only halfway. It's absolutely fine if you want to carry it to Wednesday. I just sort of want to know so that I don't rush you. So just give me a thumbs up. Yes, I'm ready for an answer, or thumbs down. Can we leave it till Wednesday and have a look at the answer then? Absolutely fine if you still need some time, don't stress. What you can always do is you can just screenshot the answer, keep it, and then finish it off and double check your answers against the memo, for lack of a better description. All right, so it seems like of the people who've given me anything, we've got thumbs up. So let's have a look, see. All right, so there were a couple things I asked you to do. Firstly, the length of BC. Now, as I said, I've given you the information that the ratio of BC to AB is 7/3. So that's exactly what I used in order to get my answer here. Strange arrow, there we go. So once I knew that, and because I knew that AB was equal to 21 units, I could go and fill in that information, and I got that BC was equal to 9, which a lot of you were putting on the chat. Then I wanted AG to GD. Now, because remember, this was a ratio of 7:3, AG, oh golly, to GD is exactly the same ratio, right? So that's why 7/3, just make sure you're putting it in the correct order. Then I wanted the length of FE. So FE is this segment all the way on the right here. You were given the whole length AE is 20. You also know that this is a ratio of 7:3, so you know what that proportion is. And again, you can go and use that to work out what you needed. Okay, so FE is equal to, I don't know where I'm going with this line of questioning I have going on here. FE is equal to 6 centimeters. Now, just remember, this is why I got myself confused. AE is the whole side, which means that the ratio for this whole side D would be 7 parts plus 3 parts. So that's where I'm getting the 10 parts from. Okay, so just remember that. But set up your ratio exactly like we've been doing and solve for your unknown. Okay, Great Tools, you were awesome tonight. We got a lot done, so you can be really proud of yourselves. Again, I know it's still the basics, but we are going to step it up, and obviously knowing the basics really is going to help us. So I'll leave it up here in case you want to screenshot. If you didn't get through all of it, that's fine. Take your screenshot, sit and work through the rest of it, and you can double check your answers against your screenshot.